All right, so 11-1 is called geometric sequences. And so what we're going to do is we're going to look at what a geometric sequence is, and we're going to look at how you find different terms in the geometric sequences. So first of all, if it's a geometric sequence, that means it has what we call a common ratio. Okay? That means that to get from one number to the next, we are going to multiply. Right? There are things called arithmetic sequences also, and to get from one to the next on those, we either add or subtract. But when we're talking about a geometric sequence, we're always going to multiply. Right? Never divide. Okay? Right? We're always multiplying. And so to get from one number to the next, we have to figure out what is that number. And so what we do is it's called a common ratio. And the reason it's called a common ratio is because to find it out, we were actually doing division to find it out. So if you notice that the first thing we want to do is it says find the next three terms in each geometric sequence. And so we find what the common ratio is by taking the next term and dividing the previous term. So you'll notice we said that it's set up here that we're going to take 4 divided by 1 and 16 divided by 4 and 64 divided by 16. So you can see that we took the second number and divided it by the first, third divided by the second, and then the fourth divided by the third. And if all of those are the same, then it is a geometric sequence. So in this case then, when I divide all of them, we are all smart enough to know that those are 4. So we call the value of r, which is called the common ratio. That's what r is. It's called the common ratio. So then to get the next 4 terms, we'll start with our last term that they gave us, 64, and then just multiply by 4. 64 times 4 is 256, right? Is that right? Okay, all right. And then to get the next term, I'll multiply that by 4, and I'll get 1,024. Okay, all right. That was real quick. Okay, and then to get the next number, we get 4,096. Okay, so we multiplied each term by 4 to get the next one. Okay, is that what you did? All right. So let's look at another one. Letter B. Our numbers are hand, 9, 3, -1, 1/3, and 1/9. Okay? The hand got copied in there. I couldn't get the thing out of the way for some reason. Okay, so that's just a 9 there. There's nothing in front of it. Okay? So it says, find the value of r dividing each term by the one before it. Okay? So the first thing we need to do then to be able to get the next 3 terms in the sequence is find out what is the common ratio. And actually, if it is a geometric sequence, I only need to do it one time. Okay? Because any one of those times, they're all going to be the same, right? So I only need to do it once. And so when I look at these numbers, what are the 2 easiest numbers to divide? -1 and 3, right? If there's ever a 1, that's always going to be the easiest number to use. Okay? So in this case, then, I can use, and I'm sorry, that is a -9 there. That's not a 9. Otherwise, this would be messed up a little bit. Okay? Right? So I take -1 divided by 3 to find r. Well, that would be the same as 3 divided by -9, wouldn't it? Okay? Which would be the same as 1/3 divided by -1, which is the same as -1/9 divided by 1/3. Okay? No matter which one of these we divide, we're still going to get negative 1/3. Now, and it's like I said, it's always multiplication, okay, when we get from one term to the next, not division. Because you might think, well, hey, to get from 3 to negative 1, I just divide by 3, right? Or divide by negative 3. How many people thought that? Just divide by negative 3. Okay? All right? And that's okay. You understand that. But the thing is that you have to look at it as multiplication, because we're going to end up with fractions. And so you have to multiply by fractions, not divide. All right. So to find the next three terms, we'll start with negative 1/9, and we'll multiply that by negative 1/3. Okay. We found our common ratio of r. The last term they gave us was negative 1/9. So we multiply negative 1/9 times negative 1/3, and we get 1/27. Here, I'm going to do something. So then we take that number and multiply it by negative 1/3. Yep, negative 1/81. And then I'll take that number and multiply it by negative 1/3. And so that one is going to be positive 1/243. Okay. So my next three terms are 1/27, negative 1/81, and 1/243. Okay. Now, notice that I used horizontal fraction bars, not ones and angles. So make sure you're doing that, okay? Use the horizontal fraction bars. All right, geometric sequences, okay, can be thought of as functions. Okay? So what a geometric sequence is actually the same as an exponential function. How many of you know what an exponential function looks like? If I was to graph an exponential function, you would know what it looked like or not. Anybody? Okay. All right, a couple people do. All right. It's actually over there on the board. It's hard to see over there where one says parent functions. But exponential functions, when we graph them, they either look like this, or they look like this. Okay. Where the one that goes up is for exponential growth, and the one that goes down is for exponential decay. Right? And so when we look at geometric sequences, they're going to have that pattern. Either the numbers are going to keep getting bigger and bigger and bigger and bigger, get exponentially large, or they're going to get really, really small, closer and closer to 0. Right? Now, there is the cases where they alternate positive and negative, and that's different, but the actual value of the number is going to get either very large or very small. Okay? So here we have position, they call it, we have the first four terms, so they call it position 1, 2, 3, and 4. And in this case, those terms are 3, 6, 12, and 24. When we're talking about sequences, we use the letters A and a subscript to represent the term number. So if it's term number 1, it would be A sub 1. The second term is A sub 2. The third term is A sub 3. And the fourth term is A sub 4. So the nth term would be referred to as a formula, basically, and we would call that A sub n. So in other words, where you could just plug the number in and get an answer. Okay. So sometimes we need an equation, which we can write as a function rule. So here they show those terms. So if we have our first term is 3, the second term here was 6, third term was 12, fourth term 24, well, then they have the nth term. So notice what happens here from one to the next. We start out with 3. Okay. Then we've multiplied by 2 one time, right? Okay. Then to get 12, we've doubled that, haven't we? Okay. So we've multiplied by 2 twice. So we have 2 to the 3 times 2 to the second power. And then 3 times 2 to the third power. Well, if you compare the term number with the exponent, what happens? Look at the term number here in words and compare it to the exponent for the 2. Okay. So the exponent is 1 less than the term number, right? Okay. So to get the nth term then, if we wanted to know what's the 8th term, then we could do 3 times 2 raised to the power of 8 minus 1, or 7. Okay? So the 8th term would be 3 times 2 raised to the power of 8 minus 1, or 3 times 2 to the 7th power. Now you can use a time symbol like the little dot. You can use a star for multiplication. Most of the time I'll end up using parentheses. I just prefer the parentheses. Okay? But you might have your own preference, and that's okay. So the pattern in the table shows that to get the nth term, we multiply the first term by the common ratio raised to the power of n minus 1. The first term of, so here's a little formula for you here then. Right? Here's the formula. This is the formula to find the nth term of a geometric sequence. Okay? If we want to find the nth term, so, and we write it as a sub n. So if they want to find the 8th term like we're doing up here, then we would have said that's a sub 8 is equal to that, because it's the 8th term we are looking for. Okay. So a sub n equals a sub 1, which is the first term, and then r is the common ratio raised to the power of n minus 1. So to be able to find a specific term, we need to know 2 things. We need to know the term number we're looking for, and we need to know, or 3 things. We need to know what the first term is, and we need to know what the common ratio is. So they want us to find the 7th term of a sequence, where the first term of the sequence is 500, and the common ratio is 0.2. Okay. So the first thing we can do is we can write down the formula. A sub n equals a sub 1 times r raised to the power of n minus 1. Yeah. So we need to know, what does n equal, what does a sub 1 equal, and what does r equal, so that we can plug them into the formula. Right. Justin, what's n? What term number are we finding? 7. Okay. All right, we're finding the 7th term, so n is 7. You like my gray or not? Okay. What's the first term? Yep. Okay. First term is 500. All right. This one is pretty spelled out for us. They don't always spell it out for us like that. All right. Colin, what's the common ratio then? All right. 0.2. So we're going to do a sub 7 equals, because I'm trying to find the 7th term, a sub 1, which is 500, times r, which is 0.2, raised to the power of 7 minus 1. So we would do 500 times 0.2 raised to the power of 6. And if you had your calculator, it'd be very easy, wouldn't it? All right. So let me pull up my calculator, and we'll calculate it together with mine. So 500 times, and you can just use the time sign here. You don't have to use the parenthesis. 0.2 raised to the power of 6. And we get 0.032. Now, one thing I want you to understand also is that if you don't know how to use the formula, okay, let's say that formula just confuses you. Okay, is that the case for any of you at times? Formulas are just confusing? Okay, all right. Sometimes they are. All right. Well, guess what else you could do? You can take your calculator and you can take 500. That's my first number, right? Okay. And if I multiply that by 0.2, I get what? Okay, here's the second number, right? And if I multiply that by 0.2 again, now I have the third number, and the fourth number, and the fifth, the sixth, and the seventh. So you could just do that. You don't necessarily have to use the formula. Okay, it's just in some cases, if the value of n is quite large, it's easier to get there than it is just to keep saying times 0.2 times 0.2 times 0.2. Okay. All right, so let's look at another one. Letter B, they want us to find with a geometric sequence where a sub 1 equals 5 and r equals 2. Hey, that's easier. Find the sixth term of the sequence. So, let's see. We would say that a sub 6 equals 5 times 2 raised to the power of 6 minus 1. And in some cases, they might be kind enough to do ones for us that we could actually do in our head, right? Okay. Let's see. If we're multiplying by 2, what are we doing? We're doubling the numbers, right? Okay. So let's see. If my first number is 5, the next number is going to be, and then, okay, so the third number is 20, fourth number is 40, fifth number is 80, so then the sixth number would be 160. So some of them you might just be able to do in your head. So you're looking at this, Megan, do you think you did them all right then? Okay, good. I figured you would. Okay, let's look at one more. No. Here they want us to find the ninth term, and they give us the first 4 terms. So a very important thing might be for you to do is to list them, all right? What's n equal? What does a sub 1 equal? What does r equal? Maybe it'll be easier that way. Okay. So they want us to find the ninth term. So there's my n. The first term is the first term, right? Okay, which is 2. Now, to find r, we pick 2 terms that are next to each other and divide. Okay. Does it matter which 2 I choose? Nope, but I always want to choose the easiest one, so I could say -6 divided by 2, -3. picking the two easiest ones. Right? If there's fractions and whole numbers, which ones are easier to divide? Fractions or whole numbers? Whole numbers are. Okay. Now, you could do 18 divided by negative 6 also, but either way, you're going to get negative 3. Okay. Now, they want us to find the next three terms. Well, once you know the negative 3, you just need to multiply by negative 3 times, right? Okay. Or they want to know what the ninth term is. To get the ninth term, we just need to multiply by negative 3 till we get there. Right? Or we can use our formula. So a sub 9 would be equal to 2 times negative 3 raised to the power of 9 minus 1. Now, this is where parentheses are very important. And notice, where do I write the exponent? The exponent's on the outside of the parentheses. And that's very important because of the negative. If this number, if your value for r is positive, doesn't matter. Okay? But when your value for r is negative, it really matters that you're working with outside the parentheses, because when I raise negative 3 to the power of 8, I'm going to get a positive number, right? Because I'm doing it an even number of times, so I'm going to get a positive number. And if it was the 8 was on the inside of the parentheses, I wouldn't. So let's look at the difference if we do it on a calculator. So we got 2 parentheses, negative 3 raised, how about one parenthesis? There we go. Negative 3 raised to the power of 8. All right, so I get a positive number, 13,122. But if I just type this in, that's going to give me a negative number. Okay? So you have to be careful. Make sure you put the parenthesis in the correct spot, because you want to make sure you get the right answer. And if you decided to, let's see, our last number is negative 54, or we could do this. We could type in 2. There's our first number, right? And our common ratio is negative 3, correct? So there's the second term, third, fourth, fifth, sixth, seventh, eighth, and number 9. Okay? Right. So you could do it that way, find the right answer also. All right. We always love application problems, right? Give me a story problem and I'm really happy. No? Shelby don't like story problems? Cheyenne's shaking her head. No way. Okay. All right. Well, the new Common Core standards that they're talking about, which you may or may not have heard about, most of that stuff they're introducing it as application type problems. So, okay. Well, you hope you might be able to use it or something. So, okay. But there's still algebra stuff that doesn't necessarily have, specific uses, but generally it's very good. So, anyway, balls drop from a tower. The table shows the height of the ball's bounces, which form a geometric sequence. What is the height of the sixth bounce? Okay. So this problem is one where, all right, do I need a formula to do this? You could use one, but you don't need one. Okay? In any of these sequences, you really don't necessarily need the formula. If the nth term we're trying to find is very large, then the formula is great, but you don't necessarily need the formula. Because what are they doing, or what's happening on each bounce? Okay? It's going down by a half, right? Okay, or if you want to say they're dividing by 2, you can say they're dividing by 2. Okay? But basically what's happening is each time it's becoming 1/2 of what it was. So I can do, I could use the formula if I wanted to. If I wanted to use it, I could. A sub 1 in this case is 300. My value for r is 1/2 or 0.5. It's up to you. And I want to find the sixth bounce, so we raise it to the fifth power, right? One less. Okay. You could do it that way, or you could just keep cutting it in half. And I would cut it in half 3 more times. So if I cut it in half 3 more times, so 75. And here's what you can do on your calculator when you have it, or at home you can do this. So I take that times 0.5, right? And then I'm going to multiply that answer by 0.5, and then I'm going to multiply the answer by 0.5. So on the sixth bounce, it will be 9.375 centimeters. Oops, I don't know what I did with those. Okay, 9.375 centimeters high.